So once more, very good afternoon to you all. I welcome you into the industrial pharmacy first. Dear student, we are on to the pellets. We had already started the topic pellet in the yesterday's lecture. And in our yesterday's lecture, we had gone through that what are the pellets, what are their advantages, what are their disadvantages, what are the different factors associated with the pellets, how we can go for preparation or production of the pellets. We said that there is a pelletization. Pelletization is nothing but the technique by which we can go for producing the pellets. And while studying the pellets and the pelletization technique, we had gone through the several number of techniques, like say powder layering, then solution, suspension spraying, then speronization, etc., etc. So there are a number of techniques. Out of these, the powder layering, solution, solvent layering, and the speronization, these are the three main techniques which are going to be very widely used. So while studying that one, we had gone through all these details in the yesterday's lecture. Now let's move to the next technique. That is what is said to be the speronization technique in our today's talk. So all this is the recap, all this is the recall of the yesterday's lecture. So this is the technique in which the fluidized bed equipment which is going to be used, the two different models, the two different designs in which there is a arrangement of the nozzle that is from the outside and inside respectively into the A and B. At the same time, you will going to find there is an adjustable rotary disc and fixed rotary disc respectively in the A and B. Then we saw that the Wooster technique, that is the solution suspension layering, that is the 30 years ago technique, and the detail associated with that, and the schematic representation associated with this process. So this was the last slide in our yesterday's talk, and we were on to this. You can see into the left side of this particular slide, there is a which is said to be the product chamber. Then there is a B which is the separator. There is a C which will represent the orifice plate. There is a D. D is nothing but the nozzle. And onto the left hand side, you can see this is the small portion which is going to be magnified in order to show all these parts. And there is a flow of the pellets. They will move upward from this side and they will comes down, and this will be in this way that can continues. Then these pellets, they will come into the chamber E, that is the expansion chamber, where that will get expanded. And this C is nothing but this orifice plate. So again, this is the magnified view of this orifice plate C. You can see in case of orifice plate, there are the orifices, there are the holes of the different diameters. And at the center, you will going to find there is a nozzle. So through these nozzle, the solution that is going to be sprayed, and through these orifices, the air that is going to be introduced, which is responsible for the flow of these pellets. And this is the Wooster technique. Then let's come to the next technique that is said to be the extrusion or the spheronization. Now, extrusion or the spheronization, that is nothing but the technique in which we are going to be allowing to pass the mass. Now, the mass, that is nothing but the mixture of these pellets, right? So the technology that is unique, and in that it is not only suitable for the manufacture of the pellets with the high drug loading, it also can be used to produce the extended release pellets in certain situations in a single step. So as it is a single step process, that means it is very easy to manufacture the pellets. So that is the advantage associated with that. It can obviate the need for subsequent film coating. So there is no need to go for the film coating if we are going for the spheronization. A variety of the extruders. Extruders, these are nothing but the devices which are going to be used in order to produce the pellets. A variety of extruders which differ in design features. There are of different design, they are of different shapes. And operational principles, the principles almost these are going to be different. We will going to come to know what are these different principles are currently on the market and can be classified as the very first one, that is the screw fed extruder. So this is the kind of extruder which will consist of a device like a screw. So the movement or the rotation of this screw device at its axis, that will causes the forward movement of the mass or the pellets. Then there is a gravity fed extruder. So gravity fed extruder that will works based on the principle of the gravitational force, gravitational pull. And there is a ram extruder. Ram extruder or the ram, that is nothing but a device which is used in order to allow the movement, like say piston movement, as you might have seen that in case of a uh, the train engines, you are going to find that a wheel that is going to be attached with that of the another wheel with the help of a rod. So that rod is nothing but the ram device. Are you getting my point? I hope all of you. So let's see all these now. Extrusion, that is the spheronization with the help of the screw fed extruder. So they will have the screws and they will rotate along its horizontal axis, and they will transport the material horizontally. So the product temperature is controlled during the extrusion by the jacketed barrel. Gravity fed extruder, it will include the rotary cylinder and the rotary gear extruders. In the rotary cylinder extruder, one of the two counter rotating cylinders is hollow and perforated. So rotary cylinder, they will consist of the two different cylinders, two different rotating devices, and these are counter rotating. That means one is going to be rotated from left to right, another is going to be rotated from right to left, or one is into the clockwise direction, another is into the anti-clockwise direction. And out of these, one is hollow and one is perforated, and one is solid one. So the hollow perforated, that is responsible for producing the pellets, whereas the solid, that is responsible for introducing the material into the hollow and the perforated cylinder device in order to produce the pellets of uniform sizes. That is the principle. Whereas the other cylinder, that is solid and act as a pressure roller, the way by which I had explained it to you just now. In the so-called rotary gear extruder, there are two hollow counter-rotating gear cylinders with the counter bore holes. So that means here, in case of the rotary gear extruder, you are going to find the two different cylinder, these are hollow and the perforated. Whereas in case of the rotary cylinder extruder, one is hollow perforated and the another is the solid. The solid one, that will going to act as a pressure roller. And in case of the rotary gear extruder, as both are perforated and the hollow, so the gears of one, they will going to act as a pressure for the another, and likewise. We are going to come to know all these in the next particular slide. You can see here the diagrammatic representation which is there onto the left hand side, that is A and B, that is associated with that of the screw fed extruder. You can see this is the jacket, right? So this is the jacket which will be having the two different way by which we can go for producing the pellet. In the very first one, A, you can see there are perforated plate onto the right hand side, whereas into B you will going to see the perforated plate. These are at the both the ends. So with the help of the screw, as it will moves or as it will rotates into this particular direction in both the cases, as it will rotates, the material that will flows into the forward direction and it will get come out of these orifices, these holes. So these holes that will excludes the larger particle to come out of this, whereas only the smaller particle or the particles or the spheres of this much diameter of this much size that will only comes out of these holes. Same as the case associated in case of the secondary, in case of second modification, you can see this is the B, whereas here you will going to find the spheres, they will come out from both the directions, right? So that is what is the screw fed extruder, and this jacket that is responsible for maintaining the temperature. Onto the right hand side, you can see that there is a schematic representation of the gravity fed extruder. You will going to see that this or this screw fed extruder, you can just compare it with that of the household device which we are using or which is going to be produced, the well-known recipe which is known as the sevayas, isn't it? Are you getting my point? Right? So that sevaya machinery that will contain the same kind of device. There is a screw fed rod and there is a loading from one end, and the screw fed, as the rod that will get rotated, it will carry out the downward movement of these that dow mass, and that dow mass will comes out like a sevaya. But here the difference is that we want the spheres, right? And we don't want the continuous mass. We wanted the separated particulate mass, right? I think there is a power issue. Just now the power had gone. There might be interruption. Yes, very correct.